Hello guys, how are you doing? Let me trust you're doing good wherever you are. Today we have this motherboard to fix. The problem with this one, the customer said the laptop is not taking power. Yes, I already disassembled it and then I removed the battery from the casing. Here is the casing for this laptop. So this is 840G3. So let us have a look at what is wrong with this motherboard. The first thing, as always, is to do the physical inspection. We need to inspect the motherboard. We see whether we can see anything physical. Then from there, we're gonna start to measure to test the main power lines, the step down that is the secondary power lines. Then from there, we'll be able to find the issue. And as I always say, the most important step to do is to do what's called the physical inspection, because over 80% of the problems were with the motherboards are things which are very visible. So when you are keen enough, you will find the problem. So now let us start by observing what's going on with this motherboard. As I can see, the first components which inject the power, as you can see, these ones, seems like somebody else repaired this motherboard before me. As you can see, there's signs of hot air exposure here. At least I know this area it is my suspect. Then from there, I can't see anything else. I can't see anything else. What about the other side where we have the step down power lines? So this is the 5.0 LDO voltage, and then I have the 3.3 LDO voltage here, and I can't see anything fishy. Then from there, here I have the line for 1.8. And then it seems like this chip also has ever been replaced for the capacitors. I don't know, because as you can see, this area there's some heat exposure. So I don't know what the hell happened here. But right now I have this area as my suspect, and then the input light that is behind this port. I have also that area being the suspect. I don't know whether I can see a small hole with this chip or what. I don't know. Maybe I'm just being paranoid. Right now I have seen some few areas. That is this area, and then the 1.8 LDO. So next thing to do is to measure. We are going to measure to see whether these MOSFETs are good. That is the first MOSFET and the second MOSFET. And then from there, once we confirm those MOSFETs whether they are good or not, then we are going to test the main power line. That is from this current sense resistor. This is where we are going to get the voltage going to main power line. And then from there, we are going to check the output voltages. That is the LDO voltages, both from the 3.3, the 5.0 and the 3.3, 1.8. And that is other lines for the power step down, whether they are shorted or not. And then from there, once we confirm there is no short in the motherboard, it will be now safe for us to plug in the power. Then from there, we are going to test the voltages. We are going to trace the voltage flow from the input line, that is from the power port, the inductor, MOSFET 1, MOSFET 2, all the way to the main power line. And then from there, we are going to check whether we have the 5.0 LDO, the 3.3 LDO, and then to 1.8 voltage here. And then from there, once we confirm those voltages are present, also we'll have to check whether we have the 1.2 voltage here for the RAM, because I believe this is the circuit for the RAM, or this one. No, this is for the charging. This is the charging circuit, and then this is the voltage for the RAM. And this RAM is the PC4, so meaning I'll expect to have 1.2 voltage, 1.2 voltage here. Remember, as we were discussing about the voltages for the RAMs, we said the 4GB RAM, the PC4, not the 4GB, the PC4 RAM needs 1.2 voltage. And I break down all the voltages needed by the RAM, starting from the PC1, whereby we say the PC1 needs the 2.5 voltage. So if this RAM was the PC1, we will expect to have 2.5 voltage here. PC2, we will expect to have 1.8 voltage at this circuit for the RAM, and not a must that to be in this location. You might find in this area, the other side, whichever the location, so long as it will be supplying power to the RAM. If it is the PC3, because also we have the PC3 RAM, we will expect to have 1.5 if it was the PC3. But if it is PC3L, you know the PC3L is the upgrade of PC3. We will expect to have a little bit lower than the PC3. That is, instead of 1.5, we will have 1.35. And then if, because this is the PC4, meaning the PC4, we expect to have what? To have 1.2. So because this is the PC4, we expect to have 1.2 at this circuit. And then for the PC5, that is the very latest generation, we will expect to have the 1.1 voltage. That is the operating voltage for every RAM. Now, we also have what's called the terminating voltage. Terminating voltage is half of the operating voltage. Meaning, if this is 1.2, we will expect to have terminating voltage to be 0.6. Same case applies to other voltages. If it is 1.1, we expect to have 0.55 voltages at terminating voltage for the PC5. Now, anyway, so I don't want to waste more time talking too much or doing a lot of discussion. So we said the first thing for us to do is to test those MOSFET 1, MOSFET 2, whether they are shorted or not. Remember, we said make your digital multimeter be your best friend. So this is my digital multimeter. Put it in continuity mode. Make sure it is pointing at the continuity mode, and then select the peeping mode because you expect to see the peeping. At the same time, we might be having the ohms measurement. Right now, it is showing OL, that is the open line. So meaning the 2 points are not connected. Normally, once we have the open line, you see, when you turn this way, that is now we have the 0 ohms resistance, meaning those probes are joined together. There is no resistance. They are one. They're joined to be one. So that is exactly what you're going to do. In case we find a component which is reading 0 ohms or almost 0 ohms, it will mean that resistor is almost joining together. So there are some components, not resistance, there are some components which are supposed to join together. Maybe side to side are supposed to be connected. So those components, when you measure side to side, then you find that you have 0 ohms resistance or below 1 ohm resistance. It will mean that component is good. However, some other components are not supposed to join from one point to the other. That is why when you put the probes into side of that component, you'll find that it has some values. And when you find that those components have 0 values, it will mean that component is either shorted or there's something wrong with it. Now, for example, here is the MOSFET 1. MOSFET 1, it will have the drain and the source. Now, the drain and the source of a MOSFET are not supposed to connect together, meaning we expect when I put my other probe to the other side and then I put another probe to the other side, I don't expect to see 0 readings. I expect to be reading oil, that's open line, or a lot of resistance, that is kilo ohms. But you can see that right now, there is no. What about if you interchange the probes? Can we get the same reading? Even if I interchange the probes, still reading oil, meaning that component is good. From there, you also need to check the source and the gate. The source and the gate also are not supposed to join to each other. As you can see, it's not joining, meaning it's also good. What about the gate and the drain? Gate and the drain also very good. So meaning that inductor is that MOSFET is good. What about MOSFET 2? MOSFET 2, same case. This one is also good. When you interchange the probes, it is also good. Meaning those what about this one? Good. This one good. Those are the MOSFETs. These are the MOSFETs which I was measuring. So I measured this MOSFET. I believe you can see. I measured MOSFET 1, MOSFET 2. And then I have MOSFET 3 and 4. These are the MOSFET for the charging. We have the low side and the high side MOSFET. And then from there, we can also have to try, because we've seen that those MOSFETs are good, especially MOSFET 1 and MOSFET 2. And then I think the next thing to do is to test whether the main power lane is shorted to the ground. You know, the main power lane is not supposed to short to ground. Why? Because that is the main line. Main line, there is no way the main line can connect to the ground. That is why you find that the electricity poles are raised above the ground. They are raised above the ground. So meaning that live wire going along that poles are not supposed to connect to the ground. In case it is grounded, it will mean that power line is shorted to the ground, and that is not supposed to be the case. Same case applies to the motherboards. We have the main power line, and then the main power line, we also have the ground running parallel to it. So let us see. One probe to the ground, and we said all these screw holes are the ground. And then after MOSFET 2, we'll have the current resistor. That current resistor is a component which joins the main power line. And actually, I think we have a problem there. And I believe we caught our problem now. You can see that main power line is shorted to the ground. Let me just bring it closer so that you can see clearly. That is my meter. My one probe is to the ground, that is to the screw hole. And then my other probe is to this current sense resistor. This is current sense resistor 1. I don't know whether you can see it. Let me just bring it closer this way. You see this one. This is the current resistor 1. That peer 1 is the one which joins the main power line and it is shooting to the ground. Who can tell me what's happening? Does it mean that exact component is the one which is shooting power to the ground? No, 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 no. That resistor is joining is like a bridge. It's bridging the power from the MOSFET 2 to the main power line. That component, because it is shooting to the ground, it means that line is the one which is shooting, which is shorted to the ground. So meaning one of the components along that line is connecting that main power line to the ground. It could be a capacitor, which I really suspect to be the one. It could be what again? It could be the low side MOSFETs because you know the low side MOSFETs are also connected to the ground. So if a low side MOSFET is shorted to maybe source to drain, it will mean that drain of that low side MOSFET connects to the ground. So meaning the source connects main power line and then it is shorted to the drain which connects to the ground. Let us see. Let us see. These capacitors, these are capacitors which are the main power line. And actually, when you measure that way, you find that they are shorted. So you will find out that all the capacitors along the main power line are behaving like they are shorted to the ground. Why? Because that main power line is shorted to the ground. It doesn't mean each and every one of those capacitors. Can you see even this one? I have another capacitor here. I'm so sorry, I don't have the microscope. I will have zoomed in, but let me just bring it closer so that you can see. I want us to discuss something about these ones. Can you see this is capacitors? These two capacitors here are in the main power line, but the output of these circuits will have these other capacitors here. So I bet these other capacitors, they don't show to the ground. Can you see? They are good. They don't show to the ground. Why? This one also good because here is the main power line, and then here is the secondary power line. Meaning this main power line is the one which is shorted to the ground. So one of the components along there is the one shorting to the ground. So for us to find that problem, it is now a big, you see, the main power line ground. This side is reading 0.9. This side is also reading 0.9, meaning this side, this main power line is shorted. Somehow it's a very big task. To find one component which is shorting that line is a bit tricky. Can you see also this circuit? This one. Here is the output. The output, I have the ground this way, and then the other side should not be the ground. And you can see it is oil, meaning it is not shorted to the ground. What about this? Have the capacitor. This side is reading 1 ohms. That is 1.2, 1.1, 1 ohms. That is, and then the other side also is also reading what? Also reading 1 ohm. So meaning these sides are also connected. So it will mean any component along the main power line is the one which is shorted. Now, how can we locate that component? Because we need to find that particular component. For us to fix this laptop, we need to find that specific component. Now, there's some other tricks which I normally try. Number one, I could check the voltage into the main power line. And then if I had the thermal camera, if I had a thermal camera, I'll use it to check which component is getting hot. Since I don't have, I'm going to use the traditional method. I was supposed to inject the voltage into the main power line and then try to feel. Try to feel the motherboard. Try to feel the motherboard whether I'll feel something getting hot. That is called the traditional method. And then number two also, I will also try and check each and every step down line. You know, sometimes you find these BD controllers. And you see these components. Let me just point to you. These are called the BD controllers. Can you see these ICs? These ICs are the one which step down to the voltages from 19 or from the main power line to the respective voltages which is needed. these chips normally are substitute to shots. They're very vulnerable. Why? Because they do receive a lot of power, that's 19. They're supposed to step down that 19 to 1.8. Meaning sometimes if you have a power surge, it will blow that chip. And then sometimes you find that that chip is the one which is shorted from the input side, now shooting the main power line to the ground and then transmitting that shot all the way to the other main power line. So I think what we are going to do to make it easier a little bit, we are going to check these step down lines. In case you get a line which is shooting to the ground, we will have our suspect there. But if we are not able to find any circuit which is getting shorted, and I say this inductor represents the power lines, the circuits, these ones. So I am going to try and check those power lines against the ground. In case I will not get any line which is shorted, now I'll have to go traditional way. I inject the voltage in the main power line, and then I try to fill the component which is getting hot. So it's not a must that you get the thermal camera for you to fix the laptops which are short in the main power line, because I have shown you easiest method to fix that. You just inject the voltage, you try to feel any component getting hot, or you also start by measuring these circuits against the ground. Sometimes you're lucky, you find a component which is shooting directly to the ground, and then your problem will be fixed. So now let us go and then we test these power lines against the ground. Let us start with the LDO voltages. The LDO voltages, that is the 3.3 and the 5.0. One probe against the ground. So this is the ground, and then another probe against this power line. So this is the LDO 3.3 or the FIRAC. Sometimes you find it's called FIRAC or always on voltages. Always on 3.3, always on voltage. Yeah, this one is good. You can see it is not shorted to the ground. What about the FIRAC 5.0? This one also is good, not shorted to the ground. Let us also check this one. We also have this one, and this is 1.8. This one is also good. What about this one? These ones are the ones which are taking power of the CPU. These ones, you can see it is pimping, but it has 9.0 ohms, meaning that's not the short. You see the short to the ground should read like 0 ohms. But when you find a reading some values, it means those are the resistance from the CPU. So 8 ohms, meaning they are good. Those are the resistance from the CPU. So meaning even the CPU is good. In the case I have 0 ohms here, it will mean the CPU is shorted to the ground, which is a very bad news. This one 18 ohms, which is also good. This one 49 ohms, very good. This one 9 ohms, which is also good. Next is this one 72 ohms, which is good. And then this one, no, this one now is bad. Can you see this one is reading 0 ohms, 0.9, which is very bad. So meaning here I have the short. It could be I have one of the components here which is shorting that line to the ground. What about this one for charging? This one for charging is always good. I have never seen this one getting shorted. Maybe in an extreme situation, but I have never. So right now, I believe we have our suspect here. So these are our suspects. So the best way to do that is to do what? The best way to fix this is to remove this. This is the BD controller for that line. This is for the RAM. So it's a BD controller. So I'm going to remove this chip because this is the first suspect. This is in any circuit. The first vulnerable component is this one, which step down the main power, that's 19, to the respective voltage. So I am going to remove that chip and then check whether I still have a short. If I still have a short, I'll proceed to find out what could be shorting that line, what could be shorting the main power line, whether they are capacitors or what. If I remove this chip and then find out no more shorts, it will mean the problem is solved. I'll just have to replace that chip and then the laptop is. So hot air on. Make sure your hot air is at around 380. Let me just use 380. And then I have air at 7. We remove this chip. The chip is out. I have removed it. Here it is. I don't know whether you can see. Can you see very small one at the belly of it? How is it? So this is the chip. Can you see? I don't know whether you've ever seen this chip before. I'm so sorry, guys. You can't see clearly. However, this is the chip which I was suspecting. It's falling down. It doesn't want us to check it. So this is our suspect. Let us see. So the chip is out. I think the best thing to do is to check again whether we still have a short. So my meter is off. My meter is off. Let's put it on. Keeping mode. And then one probe is always still to the ground. I need one probe to the ground. And then my other probe to this line which was shorted. And actually no more shots. Maybe it's still hot, but you can see we have 50 ohms. Maybe the problem is fixed. Let us check the main power line. The main power line, we said any input line should be the main power line. And actually there's reading OL. And you see, it is reading OL, meaning the short is gone. So the problem is fixed. Even though we haven't replaced that chip, but we are going to replace it. I am going to replace it right away. So let us see again. Let us verify with the other side. One probe to the ground, and we say this screw holds at the ground. One probe to the ground, and then I have another probe to the harness resistor 1. And actually this reading OL, meaning the short is removed. Now I need a spare. I need a spare parts to replace that. Let me check whether I have a motherboard which can donate for me at that chip. Here I have the donor. This is another data motherboard of the same kind. This is 840G3. And I believe we have donor here our part. So see the chip we are going to replace that. We're going to take the chip and then we solder it to the other side. And then we pray that the issue will be fixed. And then we call it what? We call it a business. You know, if it doesn't get fixed, we are not going to call it a business. And you want to be a business. Let us desolder this chip from the donor board. A lot of smoke here. The chip is out. Then we are going to transfer it to the. This is a recipient. This is a recipient motherboard. The other one is the donor motherboard. Why? It's not going. Not getting soldered. It is soldered. Is it properly soldered? I believe so. So let me have my donor aside, and then we test again. Maybe once we put the back, once we solder that chip, we will have the short back. You know, let us reconfirm that there is no short, and actually there is no short. You see, and actually there is no short. See, it is reading OL. Let me just put it this way, ground, and then here. Now it's time to see whether we did a good job or we are back again to drawing board. Find out what's going on. Before I tried to plug in, there was a sparking sound from the port. So let us see. We plug in the blue pin and then see whether these LEDs will come on. That will mean that we fix the issue. If it doesn't, it means we are in deep shit. The laptop is not yet on. Let's see. Ooh, see the LEDs. So, and the fan actually spins. Now let us connect the motherboard to the casing and then see whether we're gonna have the display. In case we will have the display, that will mean the laptop is fixed. And I am very happy. You know, it seems we are heading somewhere. Once we have those LEDs, before you could not see any LED. Before you could not see any LED. Right now, there's some LED, meaning we have a good size. We are heading somewhere. So let me just leave the screen there, and then I am going to, I just connected the cable for the display. I just connected the cable for the display to the motherboard, and then this is my blue pin. Let us plug in the blue pin and see whether we can have the display. Then the laptop is powering on, fan spinning, LEDs are there. Let us see whether we have the display. Let us, do you think we fixed it? Tell me in the comment section. It went off. Then it came back again. It actually seems like it was restarting or what? How can it restart before it displays? Do you think the problem is fixed? No, the laptop keeps restarting. It seems like the issue is not fixed yet. No, it's going on and off. The laptop is going on and off. Before I proceed, before I do anything, that chip. Let me just put this one aside. We don't have the display. The laptop is coming on and off. This circuit is the one for the RAM. Let us change the RAM. Maybe the RAM also got burnt because this is a line for the RAM. Maybe the RAM got burnt. Let me use my RAM. I don't know where I placed my RAM. I should have my testing RAM somewhere. So this is the RAM which we are going to use it to test. Again, these are different RAM. Maybe the other one got burnt because the circuit which got burnt is the, sorry for that. Sorry for that interruption. The circuit which got burnt is the circuit for the RAM. So let us hope this RAM will work because these are different RAM. Plugged in and still coming on and off. Still coming on and off. What do you think will be the issue? See the BIOS get corrupted too. I don't know whether the BIOS is so corrupted. So what you're going to do? Do you want to see? It's coming on and off. It's coming on and off. Let us plug it in for you to see. See the LEDs there. The fan is spinning. It spins for some time and then it went off. It went off. And then to come on again. It keep repeating that process. Even sometimes the BIOS get corrupted by what? The BIOS get corrupted by the shorts. I like us to remove the BIOS chip. This is a BIOS chip. We want us to reset it. We removed it and then we put it back. We see whether it will fix the issue. If it doesn't fix the issue, I think we're gonna do what? We're gonna program the BIOS. So the BIOS removed. Let us resolve this BIOS again. If it doesn't work, we are going to program the BIOS for this motherboard. This is what's called resetting the BIOS. We resetted the BIOS. We removed it, and then we did what? Then we solder it back again. I like us to test again whether the problem is fixed. Sometimes this process works. Sometimes it doesn't work. So if it works for you, say thank you. If it doesn't, good luck. It's your next step. Because from here, you'll have to program the BIOS manually. Plugged in again, still coming on, fan spinning very fast, meaning it will shut down like before. When you had the fan spinning at a very high speed, the moment you plug in the charger, it means the laptop will went off, and actually it went off. Now, give me 1 to 3 minutes to find the programmer for the BIOS, to program the BIOS, then we boot it back. We see whether the issue is fixed. So I have programmed the chip. So the chip we are going to try this one. So there are different BIOS. So we are going to test whether this one can work or not. So let us dissolve this one. It's now time to test. Like before, I am going to connect the screen. Let me just put the screen there so that you can see what's going on. Then I'm going to connect the cable for the display into the motherboard, because right now these are different than BIOS. It's connected. I'll need power plugged in. We wait and see whether it will power on. And actually, it's powered on. Fan spinning at a very high speed. Now, and actually, the laptop keeps on shutting down. What is not happening with this motherboard? Something's still wrong. Something's still wrong. I am sure the issue is not the BIOS, because right now we changed the BIOS and we still have the same issue. The problem is not the BIOS, because if it was the BIOS, once we replace the original BIOS, then we put back the original, it was supposed to do something different. Since there was a short in the main power line, there's something I'm suspecting. Something I'm suspecting. This chip here. Let us replace this chip. But before then, let us see whether this resistor is good, because there are some other resistors which normally get some issues once we have the short in the main power line. I need the beeping mode. We start with this one. It's supposed to have 10 ohms. It's having 10 ohms, which is good. This one at least 5 ohms. 5 ohms, which is also good. Let us see what my donor might donate this time round again. So let me replace the charging IC, that is the input power IC, and that small diode there. Those are other suspects which normally got some issues. This one out, that one in. Before I change the other one, before I change the IC, let us try and see again whether it will shut down, having changed that diode for the power. Still, it keeps on shutting down. But again, now I can feel this port is like still loose, and there is still okay. I'd like us to see what's actually happening within the CPU, because right now the only suspect, the only thing I feel like there's something wrong is with the CPU, because whenever you have these lines shorted, especially the lines which supplies power to the CPU, maybe the LDO 3.3, this one, even this one for the RAM. The RAM also connects to the CPU directly. So you find again when you have a short coming through that line, and then in case that short is coming from the main power line, it will kill the CPU. I don't want to assume anything, but let us test it again. Plugged in. As you wait for it to power, I need to fill the CPU. We need to fill the CPU. And the CPU is too cold. The CPU is too cold. Why is it too cold? Is it not receiving any power? So let us try and test the voltages, whether it's going to the CPU. And then the first voltage we need to find is the 1.8 voltage. I don't know whether you'll see the meter, because I would like you also to be observing what is happening. That's my digital multimeter. Now, one probe to the ground, then my other probe to this 1.8. I would like to see whether I have 1.8, which is there. You see, we have 1.8. I also need to check whether I have the LDO 3.3. I'd like to see whether I have the LDO 3.3 from here. One probe to the ground, and then here. Here, this shit, instead of giving me the 3.3, it is sending out what? 4.5, which is very bad, not good. Let's see the LDO 5.0. This one at least is fair. 5.2 is not far from 5.0, which is very good. However, here, this one, but it is fluctuating, you see? It's going up and down up to 4.1, which is too much, coming back even to 2.5, which is not good. Here, I need a maximum of 3.4. But you see, this one is keeping on fluctuating. Now, I think the better thing to do, we can try to change that BD controller for that line. Let us change that BD controller for that line. And I believe we're gonna have the spare here. Maybe that is the issue. It is not giving out the steady 3.3, which is this line. I'll need 3.3. I'll need LDO 3.3 very steady, not fluctuating. Let us try again. Let us cool it down a little bit, and then we try again. We see whether we can have the steady. We plug in again. Let us see whether it is generating the 3.3. Prop the ground, and then another one here. Still, you don't have the 3.3. And now the laptop then is not powering on anymore. It's not powering on anymore. Oh, right now it's on, and it's going off, but still we don't have the 3.3 steady. So what else is going on? Why we are not having the 3.3 in that line? Let us see what is the AC doing. The AC is getting hot. This is the chip which is supposed to control the 3.3s which are sent to the VREC, that is the 3.3 LDO. And this chip is getting hot. Anyway, I'll need time to settle and then I'll have to change this chip. I think in our next video we are going to do that right now. I'm so tired. We are not going to keep on frog jumping. This chip is getting hot actually. That's why we are fluctuating 3.3 from the 3.3 LDO line. This is very tiresome. We wasted like a lot of time. Of course, I'll edit this video. Because this is a too long video. I'll just edit and then leave the important discussion. Then the rest, I'll just have to edit it out. Otherwise, thank you so much, guys, for being patient. Thank you for watching this video until the end. In our next video, I'll give you an update about this because the next thing to do, I was supposed to change this chip. However, from my donor, I don't have it. You see? Yes, I took it long time ago. We'll just change. I'll look for the chip, then we'll change it in the next video. I don't know whether I'll do the uploads of the same video, but I'll see what I can do about it. Thank you so much, guys. Please do not forget to subscribe, share with your friends, give us some comments. And in case you're interested in learning about laptop repairs, you are highly welcome to join us. We do over the teaching, both online and offline. Whichever module you are interested in joining, you're highly welcome. Yes, and again, if you have an issue with your laptop again, do not hesitate to send it to us. We fix it for you. Thank you so much, guys. Don't forget to subscribe and see you in the next video. Goodbye.